I'm going to show you how to calculate an integral by partial fractions. If you're interested in that, keep watching. Okay, so here we have an example. So in this Mathematica tutorial, I'm going to do this example of calculating this integral by hand using partial fractions. Okay, so first of all, I'll copy it into a new cell, paste. Now what we're looking for is a way to separate the denominator into a product of two things. Now it's pretty obvious to factorize this denominator. What we have is x times x plus 1. Okay, so pulling out the x, it's the same as this. Alright, now the task is to separate this as a sum of two fractions. Once we recognize that the denominator factorizes, we want to separate this into two fractions. Okay, so far we've got this. Now let's come down and write a new step in our calculation, which will be to separate this integral, as in this right here, as a sum of two things. So I'll copy it, paste it. Okay, now on the left I want just x, and I'll have to put a numerator of something I don't know yet, so I'll just call it a. A is a function of x. Now on the right I'll have b over x plus 1. Now look, if you were to add those two fractions together, you see you would have to get a common denominator, and that common denominator would be x times x plus 1. Okay, so under that assumption, you are seeking now functions of x, a and b. Alright, so that is what you must do now. So next we want to put this back together using addition of fractions. Okay, we're seeking a common denominator. So what we do is we would have to multiply the left fraction on numerator and denominator by x plus 1. Okay, so let's do so. A times x plus 1 over x plus 1. Now with the right fraction you would have to multiply by x on the numerator and denominator. So let's do that. X and x. Okay, now that we do have a common denominator, let's add the numerators. So let's go down to a new line, paste, and I need to copy the bx, put it there, get rid of this. Okay, so these two are equal. Okay, now that we have that, we can compare the numerator of this numerator right here with this numerator right here. Okay, so we say, so x plus 2 is a times x plus 1 plus bx. Okay, now we want to solve for a and b. So let's rearrange the right hand side. So first of all, I'll expand the a over the bracket. Okay, and now we want to collect like terms. So coefficients of x and constant coefficients. Okay, now we want to factorize x out of this expression. So I'll do that. Okay, and now that we have coefficients of x and constant terms, we can compare those. So we must have a plus b equal to 1, the coefficient of x on the left hand side, and a equal to 2. Alright, so conclude that a plus b is equal to 1 and a is equal to 2 by comparing the coefficients. Okay, now you can solve that as a simultaneous system. if it's a more difficult example, but this one is really easy. You can just see what the answer is. A equals 2, and if A is 2, well then B has to be equal to -1. Okay, so let's say so B equals -1. Now that we have A and B, we can use them. All right, so let's come down here and write this integral that we're trying to calculate is equal to, oh, actually we wanted it in this form right here. Okay, so let's copy that. So we found out that A is 2, so let's replace A is 2, B is -1. And now, what do you know? Our integral is a lot easier to do, right? Because we know how to integrate 1 over x, it's log x. And likewise, integrating -1 over x plus 1 is easy too. Okay, so let's simplify this even more. So I'm going to copy this twice. Okay, and I'll just get rid of that one. Get rid of this one, pull the -1 out the front. Okay, so these two integrals right here are equal. All right, now just a little bit more, pull the 2 out, and now we've got the integral of 1 on x, or x to the -1. Okay, so another step in simplification, and we see that this is the integral of 1 on x, or x to the -1, is just the natural log of x. And this one is the natural log of x plus 1. But to see that, you can observe that the derivative of x plus 1 with respect to x is 1. Okay, so I'll just copy in a fraction because I want to enter a derivative symbol, which looks a lot like a fraction, but it's not. All right, so what I was saying is that the derivative of x plus 1 with respect to x is 1. Okay, so you see these are equal, these two. These are equal. All right, now if you were thinking of this in terms of fractions, which helps you remember the rules of differentiation and integration when you're using Leibniz's notation, well, you might think to cancel the dx, okay? That tells you that this integral is equal to the integral of 1 on x plus 1 with respect to x plus 1. Sorry, yes, x plus 1. Okay, now if you introduce another letter, let's say the letter u, where u is equal to x plus 1, well then you have the integral of 1 on x, well, the integral of 1 on u with respect to u. Okay, so let's include another line. Let's say du over u, where u is equal to x plus 1. Okay, and now we can say, well, this is just, as in the second integral there, is just equal to the natural log of u, and then now that we have this integral complete, we have to add plus c. Okay, and finally, let's put the u back in, because we know what u is, it's x plus 1. All right, and there we have the integral completed. All right, now that's how to calculate it by hand, but how do you check your work? Well, let's turn this all into a comment by putting bracket asterisk and asterisk bracket. Well, that's a different cell, isn't it? So I needed to put that here. Okay. All right, now that that's all a comment, I can show you how to calculate this using Mathematica in order to check your work. Okay, so you just write integrate, or you could use the palettes and find the appropriate symbols. And so what were we integrating? It was this fraction right here. So copy that, paste it, and I'll say with respect to x. Now that I have that entered, I'll shift enter, and you see we get exactly what we found, but the plus c is missing. Okay, so that's how you do it. Hope you learned something, and I'll see you next time. Thanks for watching.